Alright, so the purpose of this video is to create a scatter plot in the TI Nspire calculator and go through assessing the scatter plot for its appropriateness, interpreting the correlation coefficient R, and just, we're describing the relationship between the two variables. Also, down here you'll see one of the things on this is checking the conditions to see if we can use a regression analysis. There's a really good video from statisticshowto.com that I'm going to link in the description. They did a much better job of explaining that than I think I would have, so I'm just going to go ahead and link that in the description so you can watch that video to sort of help you out with that. Alright, so let's get started. So first we have this data. It's the temperature in January for 24 different locations in the United States, as well as their latitudes. And question 1 just asks us simply to create a scatter plot. Sometimes you'll be asked to sketch the scatter plot, but for this, we're just going to type scatter plot. So first thing we want to do is we want to name our variables. I think temperature and latitude would be a good example. I've already input the data, but you can see we have 24 data points match up with our 24 cities in the US. It is important to note that you do need to match up the points with each other. You don't just go through and randomly type all of the temperatures in and then all the latitudes. This is what we refer to as a paired data set. So the temperature for Albuquerque, New Mexico needs to match up with the latitude for Albuquerque, New Mexico, and so on and so forth all the way down. So now that we have that in there, what we want to do is we want to create a scatter plot because that's what the question asks us to do. So we use control. Well, there's many ways you can do it. The easiest way, push Control and Dock to open a new page, and we go to Data and Statistics, and we add a variable down here to get our X, and we add our Y variable up here. Now, it makes more sense to me that we have our latitude as the explanatory variable. The assignment that I stole this from actually has the temperature on the x-axis and the latitude on the y-axis. And frankly, that doesn't really make that much sense to me. So, I mean, the latitude, the location you're on the planet, I feel like would have more of an impact than the on the temperature than the other way around. But, what do I know? So, there's our scatter plot. Scatter plot created. If we needed to, if it gave us room here, we could sketch that. But it didn't, so we won't. Number 2 says, describe the relationship between temperature in the U.S. and latitude. So, just looking at that, it's pretty straightforward. We see that this is a negative association, meaning that as we go from left to right, it decreases. This is something I would say is probably linear. It doesn't seem to have any curve or wave or anything weird like that. And I would consider this to be strong. I think maybe this point out here weakens it a little bit. This one might be a bit of an outlier, but for the most part, this is a strong data set. So maybe it's on that line of being moderately strong to strong data. But when we compare it with the examples from our notes, I would say this one is a strong association. So the way we would write this, we would answer this, we would say there is a strong, we don't have to capitalize that, strong negative linear association between latitude, apparently not how you spell it, it's right there in front of me, and temperature in the US. Done. That is how you would answer that. There's a strong negative linear association between latitude and temperature in the US. These three things are what I want to know: the strength, the direction, and the type, right? The form, if you will. The answer to number 3 is going to be very similar to our answer for number 4 because the coefficient of correlation, very similar to our answer for number 2. The correlation coefficient R is basically the coefficient that describes the data. If it's strong, then this is a, or I'm sorry, if it's close to 1, greater than 0.7, then we say this is a strong association. If it's between 0.7 and like 0.3, we say it's moderately strong. If it's less than 0.3, then we say it's weak. And if it's positive, then it's a positive association, meaning it's sloping up. And if it's negative, then it's going to be sloping downward. So we should expect, when we do this, to find a R value that's somewhere between negative 0.7 and negative 1. It's not going to be negative 1 because this is in a perfect straight line, but I expect it to be stronger than 0.7. There's a couple ways you can do this. First way is we go back to our list and spreadsheets, and we run two variable statistics. So menu, statistics, stat calculations, and two variable statistics. Our X list will be our latitude, and our Y list will be our temperature. Now for R doesn't care which one you put as your X and your Y, but we just want to be consistent throughout the whole problem, right? When we scroll down, and there it is. Hey, I was dead on. So R is negative 0.7756. So the way you write this, R equals negative 0.7756, etc. Which means there is, why do I keep capitalizing stuff randomly? There is a strong negative linear association between latitude and, oops, I did it again, and temperature in the US. And if you're ever not sure if that's the way you're supposed to answer that question, there you go. There's a sentence stem for you. Get my face out of the way. The correlation coefficient R shows a direction strength linear relationship between X and Y. So there is a strong, there's a strength, negative, there's a direction, linear association between the X and the Y in the US. There you go. That's how you answer that question. And like I said, I'm not going to bother with answering number 4 because I think the people at statisticshowto.com did a much better job. So I'm just going to link that video in the description and you can watch that. Hope this was helpful. Stay tuned for all the other fun stuff.